Welcome to this explainer. You know, when you're looking at the colossal scale of modern shipbuilding, we're talking massive vessels spanning hundreds of meters, carrying thousands of tons of cargo. The stakes for structural integrity are absolutely absolute. There's no room for error. So today, we're going to uncover exactly how these modern megaships are kept safe from catastrophic structural failure. Specifically, we're diving straight into the rigorous testing and commissioning phase that happens long before a ship even touches the water. Let's get right into it.
Now think about a modern shipyard for just a second. We've got highly integrated 3D CAD models, massive laser-guided cutting robots, and these incredible automated submerged arc welding machines piecing the ship together block by block. With all that cutting-edge tech, you might assume the most critical testing tool is, I don't know, some multi-million-dollar AI-driven scanner, right? But if I asked you what the actual most crucial testing tool is, the answer is surprisingly low-tech. And yet, it's completely irreplaceable.
It's the human eye. Seriously, the fastest, cheapest, and hands-down most widely used inspection method in the entire shipyard is literally our oldest tool, human visual inspection. Before any complex radiation or sound wave technology is even brought onto the scene, a highly trained inspector just has to get in there and look closely at the welds holding the ship together.
Section 1. The first line of defense.
See, visual inspection actually catches more defects than any other single testing method. It acts as the ultimate frontline gatekeeper, and it operates on one very fundamental truth. A weld that looks bad on the surface almost always has internal issues too. These surface flaws, they aren't just cosmetic blemishes. They are massive, glowing red flags. Because if the surface structure is compromised, you can bet the internal root of that weld is almost certainly flawed as well.
Section 2. Spotting surface flaws. So what exactly are these inspectors hunting for? Well, one of the most common and honestly most dangerous defects is called an undercut. Basically, an undercut is where the base metal of the ship is literally eroded away along the edge or the toe of the weld. It creates this physical notch right in the steel. And that's a huge problem because it concentrates stress and can easily lead to a fatigue crack when that massive ship is bending out there in heavy ocean waves.
Another huge red flag to look out for is overlap. This happens when the molten weld metal runs out onto the base plate but just completely fails to fuse with it. It's essentially just sitting there on top of the steel, offering zero structural strength. Nothing. Inspectors are also keeping a sharp eye out for other visual cues. Things like surface porosity, which looks like tiny visible gas pores or bubbles, hairline surface cracks, high spatter, or simply an incomplete fill where, well, just not enough weld metal was deposited.
Section 3. The Inspector's Toolkit. Now, to actually spot these tiny millimeter-scale defects on a structure the size of a skyscraper, inspectors rely on a very specific hands-on toolkit. First off, the rules require a minimum of 500 lux illumination directly at the inspection surface, so it has to be incredibly bright. Then the inspector brings out a specialized tool called a bridge cam gauge. This lets them precisely measure dimensions like the crown height of the weld, the depth of any undercut, and the size of the fillet. They also use an illuminated magnifying glass to hunt for fine surface cracks, and crack detection mirrors attached along rods to check welds in those really tight, hard-to-reach spots, like deep down in the double bottom of the ship.
But you know, perhaps the most important tool of all is simply the notebook and the weld map. Nothing is done from memory here. Nothing. Every single inspection result, whether it's a pass or a fail, is systematically recorded on a detailed structural map of the ship. This ensures absolute 100% accountability for every single joint on the vessel.
Section 4. The 100% Rule.
When we zoom out and look at the scale of this operation across an entire shipyard, the rule is frankly staggering. 100%. Absolutely every single structural weld on the ship receives a human visual inspection. Just think about that for a second. We are talking about miles and miles of welded seams connecting thousands of individual steel plates, brackets, and frames, and every single inch of it is heavily scrutinized by the human eye under that bright 500 lux light.
And hey, this isn't just some casual best practice that shipyards do just to feel good about their work. It is an uncompromising legal mandate. It's strictly required by all maritime classification societies, big organizations like Lloyd's Register. Basically, if you want your ship to be certified, insured, and legally allowed to sail the oceans, you have to prove that 100% of its structural welds have been visually inspected and mapped out. No exceptions.
Section 5. The Ultimate Quality Gate.
You can kind of think of the visual inspector as the strict bouncer at an incredibly exclusive club. The gateway logic here is absolute. Step 1 is always visual inspection, or VT. If a weld fails this visual check, let's say the inspector finds an undercup or a bit of surface porosity, it is immediately rejected. Boom. It goes to step 2, where it must be repaired, ground out, re-welded, and then re-inspected. No weld gets to advance to the VIP room of step 3, which is the advanced non-destructive testing, unless it passes the human eye first.
To understand why this gateway is so strict, let's just briefly compare visual testing to those advanced non-destructive testing methods. Visual inspection catches most of your surface defects, it's cheap, it's fast, and it can realistically cover 100% of the ship. On the flip side, things like radiography, which are basically X-rays for ships, or ultrasound, well, those are used to catch internal defects. But these advanced methods are incredibly expensive, they are much slower, and they often require clearing the entire area of workers just because of the radiation hazards. Because of that high cost and time, they're only used for selective coverage on the most highly stressed joints. So visual inspection is really that cost-effective frontline triage. It ensures you aren't wasting time and money X-raying a weld that's obviously bad right there on the surface. So, to summarize the core takeaways here, the most important quality gate in modern shipbuilding doesn't actually rely on software or automation. It relies entirely on human discipline, correct technique, a minimum of 500 lux lighting, calibrated gauges, and really systematic weld mapping. It's a massive physical undertaking that proves the structural integrity of the ship seam by painstaking seam.
All right, so we've established that visual inspection absolutely rules the surface of the steel. But as we learned earlier, what if the surface looks completely perfect, but there's a dangerous void hiding deep inside the metal? How do shipbuilders guarantee the interior integrity of the steel without, cutting the ship back apart? The visual inspectors cleared the path, leaving us with a really critical question. What exactly do the X-rays and sound waves reveal when they finally look inside? That is where the fascinating science of radiography and ultrasound takes over. But I'll leave you to ponder that for now. Thanks for joining me on this explainer.